Alright, so we have a PowerPoint that I'm about to show you here. And I hope you guys will really like it because it took me a long time to do this. Attention! Yesterday a spaceship was launched called Wanahanalupi. This spaceship was able to reach a faraway planet. This planet was covered in jelly-like creatures called weirdos. These creatures have now known to us a plan to attack our planet and rule our... Well, the end. Kind of a short story, but... Your assignments. How would you feel if you walked along a wall and you saw that ad on it? How would you react? What were your expressions? Aliens. We don't know about we don't know about we don't know about aliens. We don't know yet, but I think that one day they're going to find life somewhere, somehow. And we do not know about aliens in space, but we know that they are possible. But people make up other stories about other life, though. That includes Star Trek and Star Wars. If you're a fan of those. Here's some graphs to even it out. The brash James T. Kirk tries to live up to his father's legacy, with Mr. Spock trying to keep him check and vengeful. Time-traveling Rollman creates black holes to destroy the Federation at one planet at a time. So that is the Star Trek thing. So Star Trek was made before Star Wars, a long, long time ago in a land far, far away. And then we made the concept of aliens. Fine, let's get in the education mood here because our teacher didn't get mad at us. Planets. Possible materials. They're made of gas, duck, or rock, or even sulfuric acid like Jupiter. How it is formed. It really depends on what the material in the planet is. Oh, I got cut off there. What does it do? It does nothing, really, as far as we know. Black holes. Possible materials. Gravity. How it is formed. When something gets too strong gravity and literally flips itself inside out. That is true. It is very unlikely, but the Earth could become a black hole, and it could tear the sun and the other planets apart. Pluto, however, and Eris, two other planets in our solar system, are way too small for that to possibly happen. Well, what does it do? It squashes and pulls everything inside of the black hole forever. It never, ever escapes. That's pretty big. Black holes continued. Guys, you are very lucky you live on a planet where there are no black holes close. Because there are some big ones. The mini black holes. Mini black holes are small. Then there's stellar mass black holes, and then there's intermediate black holes, and then there's supermassive black holes. Mini black holes. See, we don't see black holes because black holes don't give off any light of their own. So how do we see these guys? Well, this is an artist's drawing that we have right here. And there's another one. How do we know they're there? Because actually, usually what we do is we look at the rays behind it so that we can check that there's possibly a black hole there. Stellar mass black holes. A stellar mass black hole is a star-created black hole. Stellar mass equals star, if you don't know that. It means star made anything. So a stellar mass made anything is a star made anything. Intermediate black holes. The red is what we don't know. The orange is what we thought we know. And the yellow is what we know. Look at the 1700s. We thought we knew everything, didn't we? But look how much we didn't know. Look at the 1800s. We still don't know a lot, but it's the same as the 1700s. 1900s, we're starting to find stuff out about black holes, it looks like. And in the in the 21st century, we've now found out that there is a lot of stuff we don't know. See, that red just kept there because we still don't know a ton. And look how much we know. So we still don't know a lot. It's about 8 point, I don't know, 1. Supermassive black holes. And we've got a video here. Alright. If you would allow me to do a 3-minute video, that would be great. Stupid ads.
When I set a goal, I never settle for second best. So when I want a new phone, I flip that last gen on eBay for the win. Take it away, mother.
Right now, get up.
Okay, this sucks. Skip this. Okay, I really like that. That, to me, I just love that. Now let's get back to this, and I'm worried about our time, so we may have to separate this into the 2 videos. The black hole map. So look, this, so the middle, that kind of the I don't know what you call that, reddish, orangish thing right there. That is the singularity, the black part of the black hole. The event horizon is the next pink layer up. That is where everything gets sucked in, and everything gets sucked in forever. And the circulation disk is the kind of the disk that circles around the black hole that we mostly cannot see. Neutron stars. Neutron stars are actually one of my favorite concepts in the star life cycle, and we'll talk about them, I think, on the next slide.
Dun, dun, dun.
Oh yes, please do. Because what you're about to hear you may not like. So this is called a magnetar, and even by looking at that, I just don't even want to get too close to that. That is a magnetar. You can even see those rays moving off there. Guys, if that guy came too close to our planet, not even the magnetic force field entered ours, but if that guy got too close to us, all the iron will be sucked out of our jewelry, and that's what all the hold on to your jewelry is about, but, and all the iron will be sucked out of our blood. I know that sounds kind of yucky, that's why we don't like these. But guys, these are almost the size of our moon, and their magnetic force fields are bigger than a supermassive black hole. They're huge. They're strong. Red giants. This is the first picture here is what is supposed to be a star, but I'm not exactly sure about that when I was looking for photos on here. And then next is the red giant. This is our star. This is our sun, okay? It's going to start out in kind of that pinkish star that we show right there, and then it'll swell out to a red giant. If we replaced a red giant for our sun, it would we'd be boiled alive. So would Venus, so would Mercury, so would Mars. It will come out to Mars. And I'm almost done with my time here. But then it would collapse into a white dwarf. The core would go and then the sun would collapse into a white dwarf, and it would stay that way for, well, maybe until a black hole sucks it up, but we don't know. Red supergiants. So, if we replaced, let's just say this, if we replaced a red supergiant for our sun, which I definitely don't want to do, Jupiter will be boiled alive and Saturn will be boiled alive. It would come out to Saturn. To Saturn's orbit. Now, it wouldn't become a white dwarf, it will become a neutron star and then a stellar mass black hole, but anyway. That is for an O star, which are like millions of times bigger than our sun. An O star. This is a Wordle. Look at the Wordle below that I made. These are things that we don't like, that are terrifying for us. Magnetars, as you see, is one of the bigger ones. White dwarfs is there too. Black holes is there, big. Neutron stars. Neutron stars aren't that big to us, but they're not something we want to come in contact with because they spin very fast and they could collide to us anytime they want. Red supergiants are just, well, they're not that big, but you know, Saturn's a pretty big thing. And I have 2 more minutes on this time, so I think I might just end it here because this is kind of funny. So if you watch the next video, you'll do more.